When a computer receives data over a network, it faces an immediate challenge. Multiple applications are running simultaneously: a browser, an email client, a file transfer tool, and all of them may be receiving data at the same time. How does the operating system know which piece of data belongs to which application? The answer lies in a mechanism called multiplexing, and the technical tool that makes it work is the concept of ports. This lesson builds directly on what you already know about TCP and UDP at the transport layer. You learned how TCP establishes reliable connections using the three-way handshake, and how UDP sends data without prior setup. Now we dig into the addressing system that sits on top of those protocols: port numbers. What is a port? A port is a 16-bit numerical identifier, meaning it can take any value from 0 to 65,535. It is not a physical slot on your machine. It is purely a logical concept managed by the operating system. When an application wants to communicate over the network, the operating system assigns it a port number. This number is included in every TCP or UDP segment that is sent or received, right alongside the source and destination IP addresses. Think of it this way: if an IP address is like the address of a building, then a port number is like the apartment number inside that building. Two different tenants, applications, can live in the same building, same IP address, but they each have their own mailbox, port. For example, when your browser sends a request to a web server, that request includes the destination IP address of the server, the destination port number, typically 80 or 443, depending on the protocol, the source IP address of your machine. A source port number chosen dynamically by your operating system, usually a high number like 52,340. When the server responds, it sends the data back to your IP address and to that specific source port. Your operating system sees the port number and routes the incoming data directly to the browser process, not to your email client, not to your music player, but specifically to the browser tab that made the request. Multiplexing explained. Multiplexing is the process of combining multiple communication streams over a single network connection, using port numbers to keep them separate and identifiable. Without multiplexing, your computer could only handle one network conversation at a time, which would make modern computing completely impractical. Here is a concrete example. Suppose you are doing three things at once. 1. Browsing a website. Your browser talks to a web server on port 443. 2. Checking your email. Your mail client talks to a mail server on port 993. 3. Performing a DNS lookup in the background. Your system queries a DNS server on port 53. All three conversations happen simultaneously over the same network interface, the same IP address. The operating system manages them by assigning a unique source port to each session. Each incoming packet carries a port number that tells the operating system exactly where to deliver the data. This is multiplexing in action. The same mechanism works at the server side too. A single web server with one IP address can serve thousands of simultaneous clients, because each client connection is identified by the combination of the client's IP address plus the client's source port. Two different clients connecting to port 443 on the same server are perfectly distinguishable because they come from different source IP addresses or different source port numbers. The three categories of port numbers. Port numbers are divided into three official ranges, defined by the Internet Assigned Numbers Authority, which manages global numbering standards for Internet protocols. Well-known ports, 0 to 1023. These are reserved for standard, well-established protocols. Only privileged system processes, running as administrator or root, are typically allowed to open a listening service on these ports. These are the ports you need to know best for cybersecurity and DevSecOps work. Registered ports, 1024 to 49,151. These are assigned to specific applications that have registered them with the Internet Assigned Numbers Authority, but they are not as strictly controlled. Examples include port 3306 for MySQL databases, port 5432 for PostgreSQL, and port 8080 often used by web application servers during development. Dynamic or ephemeral ports, 49,152 to 65,535. These are used temporarily by client applications when initiating a connection. The operating system picks one automatically. Once the connection closes, the port is released and may be reused by another application. Key well-known ports and why they matter. For anyone working in cybersecurity, memorizing the most critical well-known ports is not optional, it is foundational. Here are the most important ones. Port 80, Hypertext Transfer Protocol, HTTP. This is the default port for unencrypted web traffic. When you type a web address in your browser without specifying a port, and the address starts with http://, your browser automatically connects to port 80. HTTP is a clear text protocol, meaning all data, including any credentials or sensitive information, travels across the network in a readable format. From a security standpoint, HTTP on port 80 is dangerous for any sensitive interaction. An attacker who can intercept traffic on the network, a man-in-the-middle attack, can read everything without any effort. Port 443, Hypertext Transfer Protocol Secure, HTTPS. This is the encrypted version of web traffic. HTTPS wraps HTTP inside a security layer called Transport Layer Security, TLS, which encrypts the data before transmission. When a user connects to a banking site, an e-commerce platform, or any site that handles passwords, the browser connects to port 443. From a pen testing perspective, you always want to check whether a web application enforces HTTPS or allows fallback to HTTP on port 80, because that fallback can expose credentials. Port 53, Domain Name System, DNS. DNS is the protocol that translates human-readable domain names, like www.example.com, into IP addresses, like 93.184.216.34. Every time you visit a website, your computer almost certainly makes a DNS query first. DNS operates on port 53 and typically uses UDP for standard queries, because speed matters more than reliability for short lookups, but switches to TCP when responses are too large to fit in a single UDP packet, or when performing zone transfers between DNS servers. DNS is critically important in cybersecurity for several reasons. First, DNS traffic is often not filtered or inspected as carefully as web traffic, making it a common channel for data exfiltration, DNS tunneling. Second, DNS cache poisoning attacks can redirect users to malicious servers by injecting fake DNS records. Third, reconnaissance tools like Nmap and enumeration techniques often start with DNS queries to discover what services and subdomains exist for a target organization. Other ports worth knowing. Port 22, Secure Shell, SSH, used for encrypted remote command line access to servers. A common target for brute force attacks. Port 21, File Transfer Protocol, FTP, used for unencrypted file transfers. Like HTTP, it sends credentials in clear text. Port 25, Simple Mail Transfer Protocol, SMTP, used for sending emails between servers. Port 110, Post Office Protocol version 3, POP3, used by email clients to download mail from a server. Port 143, Internet Message Access Protocol, IMAP, a more feature-rich email retrieval protocol. Port 3389, Remote Desktop Protocol, RDP, used for graphical remote access to Windows machines, frequently targeted in ransomware attacks. Port 445, Server Message Block, SMB, used for Windows file sharing. The famous Eternal Blue exploit used by WannaCry ransomware targeted this port. How port scanning fits into pen testing. Understanding ports is the direct foundation for network reconnaissance and penetration testing. When you run Nmap against a target, what you are fundamentally doing is probing port numbers, testing which ports are open, a service is listening and responding, closed, no service is listening but the host is reachable, or filtered, a firewall is blocking the probe. For example, running a basic Nmap scan against a host might reveal port 22 open, SSH is accessible, check for weak credentials or outdated versions with known vulnerabilities. Port 80 open, an HTTP web service is running. Investigate further with web application testing tools. Port 443 open, an HTTPS service is running. Check the TLS configuration and certificate. Port 3306 open, a MySQL database is directly exposed to the network. This is a major red flag in most contexts. The combination of open ports gives you an attack surface map. Services running on unexpected ports, like a web server on port 8888 instead of 80 or 443, may be development or admin interfaces that are less secured. Hidden or non-standard ports are a classic security through obscurity mistake. They are not inherently more secure, just slightly less visible. Firewalls and port filtering. Firewalls operate largely by controlling which ports are accessible from the outside. A basic firewall rule might say, allow incoming TCP connections to port 443, allow incoming TCP connections to port 80, deny everything else. This dramatically reduces the attack surface by hiding all other services from external attackers. From a DevSecOps perspective, understanding ports allows you to properly configure firewall rules in cloud environments, such as security groups in AWS or network security groups in Azure. Ensure that development ports, like port 8080 or 5432, are never accidentally exposed to the public internet, and validate your infrastructure security as part of a continuous integration and deployment pipeline. A practical summary. To solidify your understanding, here is a clear summary of what you must retain. A port is a logical 16-bit number, 0 to 65,535, that identifies a specific application or service on a host. Multiplexing allows multiple applications to share one IP address by assigning each a unique port. Well-known ports, 0 to 1023, are for standard services and require elevated privileges to open. Port 80 is HTTP, unencrypted web traffic, always flagged as a security concern for sensitive data. Port 443 is HTTPS, encrypted web traffic using transport layer security, the expected standard for any serious web service. Port 53 is DNS, critical to understand for reconnaissance, tunneling attacks, and cache poisoning. Port scanning, using tools like Nmap, is the primary technique for discovering what services are running on a target. Open ports represent the attack surface. Reducing unnecessary open ports is a core security hardening measure. This knowledge directly prepares you for hands-on activities involving Nmap scanning, firewall configuration, and web application pen testing, all of which require instant recognition of what a given port number implies about the service running behind it.